One of the important things in a titration is that that titrant that we're using is known to a very high degree of accuracy. So to find that concentration to a very high degree of accuracy, we use a technique known as standardizing our solutions. And what we do, just to give a specific example, say we make a solution of hydrochloric acid. And it's difficult to make a solution of hydrochloric acid where we know the concentration exactly. And so often what we do is we aim for an approximate concentration, and then we find out what the exact concentration is by reacting it with a known standard. Something where we know very accurately how many moles are present, so we know how much reacts with our solution of HCl. So for example, and some of you will have done this by this point, we can use a primary standard that we can measure by weighing it out and being able to get a very accurate mass from this. So the primary standard that's very commonly used with HCl is sodium carbonate, Na2CO3. Now, why is sodium carbonate used? We could use any base in theory, will react with HCl. The reason we use sodium carbonate is because it is high purity, so it's very easy to obtain it where you have just sodium carbonate and very few other impurities that are present at any any significant amount. Because otherwise, when you weigh it out, you'd be weighing those impurities as well and would not be able to get an accurate mass. And your mass, if your mass is not accurate, then your number of moles is not accurate, and you don't have an accurate measure of the actual concentration of your solution. So high purity is really important. It needs to be shelf stable, so something that you can keep in your lab and store and be confident that it's not decomposing into something else, or anything like that, or taking on water or things like that. And another thing that you want to be able to do with it is be able to dry it. And the purpose here is we want to remove water. Water in the atmosphere likes to cling to lots of stuff, everything. And so we need to remove that excess water that has clung to our standard to be able to get an accurate mass. So it's the same idea with the high purity. This is a way of ensuring high purity, is it's something we can put in the oven and it's not going to decompose. So sodium carbonate is an example of this. There are other primary standards that we can use, but they will have these similar properties. And we can standardize different things. So, this is an example of how we'd standardize HCl. We can also standardize sodium hydroxide. We can standardize different sorts of mixtures. But, this is the basic idea, is that we take our solution that we want to know the concentration of, react it with a known amount of that, of a standard that we can measure very accurately, usually by weighing, and that lets us find a very accurate concentration for our solution we like to use as a titrant.